All right, so in this lesson, you're definitely going to want to use a graphing calculator, or you can use Desmo's graphing calculator, and if you just Google that, it will come right up and you can graph functions that way as well. So the learning target for this lesson is I can graph nonlinear functions and identify the domain and range of the function. And so nonlinear functions are anything that are not lines, so we're going to look at all functions now. And then domain and range we're going to define actually right now, and we'll learn about that throughout this unit or this lesson. So first, the domain is all the possible x values of a function. So input and x values, that's domain. Okay, so think of domain as x. Range is all possible output values or your y values of a function. Okay, and so just some notation tips. If you remember from the beginning of the year, these are our number sets. So we have the natural numbers, the whole numbers, integers, rational numbers, irrational numbers, and then the real numbers. Domain. So let's look at some examples of what domain and range actually are, and then we'll be looking at examples as we go through this lesson. So example number 1, you might see something like a mapping diagram where there's not necessarily a rule to get from one input to the output, but it's already kind of laid out for you like this. And so the domain would be all of the numbers that are in the input circle, and the range would be all the numbers in the output circle. So the way we kind of notate this, and the hardest part about domain and range, I think, is the notation of it, is we put it in what's called set notation. And set notation is basically like a list of numbers. So in this case, I would put 3, 5, and 7 in this set, which tells me my numbers are only 3, 5, and 7, and they're not 4 or any numbers in between. So you use this notation. This is called set notation when you're just listing out specific numbers. And so the same for my range in this case, my output, I'll put it in set notation, so using kind of those curly brackets, 2, 4, and 11 for this set. And that's really it. Okay, so these are like basic examples. So let's look at some ordered pairs. So say you have a set of ordered pairs, and if you notice, the curly brackets are there as well, which is just saying that these are the only points in the function. There's not anything between those points, or it's not part of a line or anything like that. They're just kind of random points. So the same type of thing, I'm going to pick out all my x values. So I'm going to circle my x values in blue. So those are all the first coordinates there. So my domain is 1, 2, 3, 4, 7, and 5. So those are all those numbers, but no numbers in between. And then my range is going to be all the y values. So that would be 1, 4, 9, 16. There's another 9 there, but I don't need to put it in my domain because I already have 9 there. And then 25. So if a domain or a range is listed twice, you only need to put it once in the set. I need to know it there. Okay, so those are 2 examples, 2 pretty basic examples. So that's only when you have specific numbers. But say you have a range of numbers, no pun intended, or so a continuation. So this graph is a continuation. It goes from this point to almost this point. And if you remember from our inequalities unit, whenever a circle is open, it means that it's not in the function. Means number is not in the function. So like 2 in this case is not in the function. Okay, so when I list my domain, there's a couple of different ways I can do this. So I'm looking at my x values for all of where this function is defined. So I'm going to go to the farthest place my function is defined. So I see the farthest place here, and so I'm going to go to my x-axis. So -3 is my least x value. Then I'm going to go to the farthest right for my function, which is right here. And so there's an open circle at 2, but it goes right up until 2. So it goes up to 1.99999, but it doesn't hit 2. So the way I might denote that, there's 2 different ways I can do it. So because my function does include 3, there's a closed circle there. I can use a bracket, and then I can put -3. Bracket means equal to. Okay? So then I can go, I can say I'm going from -2 or -3 all the way to 2, but I'm not including 2. That is a parenthesis. So a parenthesis in interval notation means not equal to. Okay. You could also denote it using kind of what we've done before. So you can do, my farthest to the left is -3, which is equal to x, but x is less than 2 and it's not equal to 2. So this is another way. So you can denote it either way. You have to be aware of both because of multiple choice options. So the region sometimes likes to denote it like this, or they denote it like that. Okay, so domain is x. Those are all my x values. Now I'm going to look at my y value. So I'm going to look up and down. So the farthest up my graph goes is 4 here. And there's no open circles there, so 4 is included in the function. The farthest down my function goes is right here, which is at -5, which again is included because there's a closed circle. So my range, I can write my range. You always go lowest to highest. So my range includes -5 all the way up to +4. So then I would use 2 brackets to do that. And then I can also write it in interval notation like -5 y, because y's are my range values, equal to 4. So y's are go from -5 to 4. So that's how you kind of read that. So either notation you can use, but you might see both say on a multiple choice. You just have to kind of be aware of what those things mean. Okay, now let's look at graphing some functions and then also telling the domain and range there. Okay. All right, so part of this is just showing you where the buttons are on your calculator. And then part of it is looking at the domain and range. So it says graph the equation y equals the absolute value of x for the interval -5 when x is -5 to 5. So this is over a specified interval. So this, they're both included, right? But this just means I want to graph from when my x values from -5 to 5. Okay, so let me show you how to put it in your graphing calculator. So anytime you're going to graph, you're going to go to y equals. And the easiest way to get to absolute value is to go to second and then 0, which says catalog. And ABS stands for absolute value. It's the first one. And then it should give you absolute value symbol. And then I'm just going to put X in the middle of it there. All right, so now I'm going to look at my table. Well, first I'm going to look at the graph. So it's a V, okay? So it's going to look like that when I graph it. So when I graph it, though, I only want to graph the points from -5 to 5. So I'm going to put my table where it's equal to -5. So I'm just going to start at -5, and I'll just graph till when I get to 5. So -5, 5 would be my first point. And then I have -4, 4. And if you see, it'll just kind of make like this V here. Like that. And then it starts to go back up. And because it only wants me to go to 5, this is what's called a restricted interval. I'm not going to put arrows on the end of it because it doesn't want me to graph the whole thing. Okay. So what are some things you notice about the absolute value function? Well, it is a function, right? It passes the VLT, vertical line test. That's from like unit 3. It also has a vertex. It's in the shape of a V. Shape of V. And maybe from left to right it decreases, then increases. Okay. So now let's look at the domain and range of this function. Because it's on a restricted interval, my domain was given to me. It wanted me to go from -5 to +5. So that's the same. So you could either write it like this, just like it was given to you in the question, or you could write it from -5 to 5. This is interval notation. Okay, either one. Okay, so now the range. The range is my y values. And so I'm going to look at my y-axis. Where is the farthest up my function goes and where is the farthest down my function goes? So the farthest up my function goes is like here, which is positive 5, and the farthest down it goes is right here, which is 0. So my range will be from 0 to 5, or you could have written it as 0 is less than or equal to y, which is less than or equal to 5. And so that is that range of that function only over the restricted domain, or it just gives us a specific place it wants us to graph. Okay, now let's look at so that was an absolute value function, though there's some varying types of absolute value functions. Let's look at exponential functions. Okay, so we're going to graph actually two. I'm going to graph g of x in blue and h of x in red. Okay, so I'm going to do g of x first. So I'll just type in my calculator, y equals 2 to the x power. So I'll use 2, and then I'll look at do the caret, and then x there. And so I do want to look at my graph first, just to see kind of what my shape should look like. So it's a curve that kind of starts off really close to the x-axis, and then it increases really, really fast. So I'm going to look at my table. And what I want to do is I want to pick out points I can plot relatively easily. So like these are up here are a lot of decimals, but you can see that my numbers continue to go up. So they'll keep going, but they're going to be really hard to plot. So I might not plot all those. I might start where I can plot easily. So like negative 1.5 I might plot first. So negative 1.5 would be like here. And then I could even probably plot negative 2.5. It would just be really, really close to my x-axis. And so I might not plot the rest of the points that are decimals, but I could draw an arrow there to show that it goes on forever. And so now I'm just going to kind of continue to go up. So 0, 1 is my next point. That's an easy one to plot. And then I can do 1, 2. And then I can do 2, 4. And then 3, 8. And I think that's the last one I'm going to be able to plot on this grid. So I'm going to connect my dots in a curve the best I can. And at the top, I'm going to draw an arrow to indicate it goes up forever. And in this way, I'm going to draw an arrow to indicate it goes this way forever. This is kind of where we have to do some thinking. So I see that my line gets really, really close, but will it ever go below that 0 or that x-axis? So what I'm going to do is I'm going to kind of look at all of my, I'm just kind of scroll up and see, will I ever have a negative number? And I'm looking all the way at negative 47, 51, and there's still not any negative numbers. This is all scientific notation, which means the number is really, really small, but there's no actual negative numbers. So this graph will never actually go below the x-axis. And the reason is because it doesn't matter what I put in for x here. Say I put in 200 or negative 227, right? I will always get a positive number. And that's because, remember in our exponents unit, we learned about a number with a negative exponent can be written as like that. Those are equal to each other. And this would never be a negative number. It will just be a really, 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 really small number. So exponential graphs, they will never go below 0 or x-axis because they will never, unless they're shifted up or down. But just as a basic function like 2 to the x, it will never go below 0 because exponents will never give you a negative number. Okay, so that's important. Another characteristic about this is that it increases slow and then fast. Okay, So this is a growth exponential function. The red one is actually going to be